Hello everybody, I'm Gleb and today we're going to talk about 5G, Massive MIMO and beamforming aspects. As you may already know, in 5G, the mainstream is using multiple antenna elements arrays for base station and even for user equipment. So today I'm going to talk about advantages of such systems, disadvantages. Also, I will tell you about aspects for FDD, TDD, and practical aspects in terms of deployment. So let's look at advantages. When it comes to advantages, this is a new concept. Beamforming in 5G, this is a completely new concept because we go from sector-oriented cell to beam-oriented cell. This is a huge step for mobile telecommunication, I believe so. In previous generations, everything related to signals, related to user equipment location, it was kind of a sector-oriented. So we basically talking about sector-oriented cell in this case. But in 5G, if we use Massive MIMO systems, we can form multiple beams. We can form all energy in one necessary direction, for example. And of course, this will lead to beam-oriented cell because everything will be related to beams, to particular beams for particular users. This is a completely paradigm shift, I would say. So the next advantage is, we can call it user-specific or cell-specific beamforming. So we can use massive antenna arrays to beamform narrow beams for particular user. And at the same time, we can form antenna pattern in that way, so other users will not interfere with the necessary user. So this is again completely game-changing technology. When it comes to cell-specific beamforming, we can refer to such cases when we need to form borders of cells using beamforming, for example, to cover skyscrapers, to cover verticals for buildings, yes, or we can form specific borders for cells for the purpose of load balancing or for the purpose of changing cell areas, I would say. So yes, we can say user-specific and cell-specific beamforming. Also, using multiple antenna elements arrays, we can achieve high diversity gain because more antenna elements we have, more diversity gain for transmitter and for receiver we can get. We can cope successfully with fading of signal, for example. This is very useful thing as well. And of course, multiplexing gain is when we can use such antenna system to form multiple beams for multiple users. And at the same time, they will not interfere with each other. Yes, because all necessary energy will be formed in particular direction. This we can call multiplexing gain. Also, Massive MIMO systems and beamforming technology very good for initial access. I would say this is a kind of a new feature for 5G because in previous generations, for example, in LTE, we also used beamforming, yes, but in 5G we can use beamforming even for initial access. and not only from base station side, yes, but also from user equipment side. So both network elements, they can form their beams, yes, towards each other to gain accessibility, to have more probability for successful access to network. And this is very important concept as well. Also, massive MIMO systems and beamforming very suitable for enhanced mobile broadband, because more energy you can concentrate in one direction. It means higher SNR, signal to noise ratio, you can achieve in particular point of location, yes, for user equipment. Higher SNR, it means higher order modulation, and high order modulation, it means high throughput. So beamforming very good for enhanced mobile broadband. Also, beamforming can be very good for Internet of Things, for devices located deep indoor, when we can't reach these devices using usual methods, usual antennas, traditional antennas, yes? So this is also very good for Internet of Things. Beamforming can be very useful for URLLC cases, yes? For reliable connection, for connection with low latency, because higher CNR we can achieve. It means that low level of retransmission, it means less retransmission we can, the channel can have, yes? Less retransmission, it means less latency in such communication. At the same time, higher CNR, it means that will be less error rate in such channel as well. So actually beamforming is very good for latency and for reliability. And of course, beamforming very useful for millimeter waves and particular fixed wireless access cases. Yes, when we can form beam toward CPE, customer premises equipment, yes. This is a kind of equipment installed in-house or located somewhere, mounted, wall-mounted, for example. And of course, beamforming and massive MIMO techniques can be good for self-backhaul concept, is when it's pretty similar to fixed wireless access, yes, but instead of CPE, at the end of such network will be next base station. So in this case, beamforming is used as a kind of radio transport, as a kind of a microwave transport for next base stations, for example, from macro base station to micro cell. So this was advantages of massive MIMO and beamforming techniques. Now let's look at disadvantages. Okay, now let's talk about disadvantages of such system. So first of all, I would like to talk about multi-user MIMO mode, because for such mode, the capacity for one user will not grow so fast as the capacity of all system. I mean that multi-user mode can be very good for enhanced mobile broadband traffic, for hotspot, for dense urban applications, yes? But in case of burst traffic, in case of texting, messaging, these users will not gain benefit from such multi-user mode, because again, multi-user MIMO is more about network throughput, is more about cell throughput. than user equipment peak rates. Another problem actually related to that is power allocation task. This is an optimization task. More antennas such system have, more complicated this optimization task becomes, because such systems should allocate all power equally, simultaneously to all necessary spatial channels for all necessary user equipments to support required CNR for every spatial channel. And this is very complicated task. This is optimization task, and it can be some limitations from hardware, for example, or from power consumption, or some limitations from government regulations, yes? Another problem is pilot contamination. Pilot contamination, this is not a new thing. Pilot contamination is when the system cannot distinguish two pilots sent from, for example, from two users. Actually, there is probably only one solution, is use pilot reuse. Pilot reuse in order to avoid such contamination. But again, resources usually not so available, limited, and this can be a problem as well. Okay, and now let's talk about TDD and FDD aspects, and also let's talk about deployment aspects. So first of all, I would like to say that Massive MIMO and beamforming very suitable for TDD mode, because in TDD mode we can have reciprocity. Reciprocity is when we can estimate downlink channel by using signals from uplink from user equipment. This makes TDD mode very suitable for Massive MIMO, for beamforming techniques, because you don't need many pilots in this case. And at the same time, for FDD you need more pilots, at least in 2 times, and this can be quite complicated task. When it comes to practical deployment, before deploying Massive MIMO system, you should consider that there will be some high requirements for optical lines, for front haul from back haul, because such system will transmit and receive large amount of information, and this is a very important point to think about your transport system. Another point is large power consumption. Usually such antenna system, it is an active antenna system with large power consumption. Also such antennas array can be large in size, especially this is for sub 3 gigahertz system. So size can be a question, and very high, very heavy such system can be. And also I would like to put the cost of such antenna arrays. Cost. So another point is, before deploying Massive MIMO antennas, you should think about what is the deployment scenario, because it will impact on number of antenna elements in vertical or in horizontal direction. For example, you need to deploy Massive MIMO antennas for dense urban environment when there are a lot of high buildings, skyscrapers, and you need to serve users in vertical directions mainly. So in this case, you need to have more vertical antenna elements for such system. And let's consider another case, is rural environment. For a rural environment, when antenna height is usually much more higher than user locations. Yes, for this case you need to antenna elements with many horizontal antenna elements in order to serve better users in horizontal direction. So all of these aspects should be taken into account when you deploy your Massive MIMO and beamforming system for 5G NR. I think that's all for today. If you have any questions, you can leave your questions below or send me to email. If you like this video, you can like and subscribe. So in my next videos, I'm going to talk about antenna ports, virtual, physical antenna ports. We will consider how such antenna arrays consist of different sub-arrays. So this will be very interesting. So stand by with Understanding IoT channel. Goodbye.